Okay, so this is the notes for 1.5 using graphs and tables of functions. You should have already read section 1.5 in your book. If you haven't, you might want to just pause the video at this time, go back, make sure that you've read that section. I'm going to start out right away with an example problem here. It says the following. It says the graph below gives the distances Maria traveled during a 7-hour trip. She drove some, then visited a historical museum. After visiting the museum, Maria drove some more and then stopped for dinner before returning home. Which variable is a function of the other variable? Express this relationship in f of x notation. Which variable is a function of the other variable? Remember, it's dependent is a function of independent. So that the answer to that first part of that question is we have to figure out which one's dependent upon the other. Well, distance is dependent upon time. Therefore, d is a function of t, or distance is a function of time. Okay? Then it says express this relationship in f of x notation. Well, what we can then say is f of t is equal to the distance. Part B says state the domain and range. Well, the domain, remember, is the values that you can have for your independent variable. Or from a graphical standpoint, it's going to be the values of the horizontal. Okay? Well, we know, if we're thinking about this just from a word standpoint, it says Maria traveled on a 7-hour trip. Okay? So if you think about the values, we can't put in a value of 8 for time because she's only been on a trip for 7 hours. So the values for our domain are from 0, or from no time at all the way up to 7 hours. Now we can also see this graphically along our x-axis. That's the possible values of, or excuse me, in t-axis, that's the possible values of t. So when we state our domain is the values of t from 0 is less than or equal to t is less than or equal to 7. The range is the values of d, the distance, and the distance traveled. Well, although our graph goes up to 150 in terms of the way we have it broken up here, the highest that the actual curve goes is right here at 100. And so it goes from 0 to 100, so our domain, or excuse me, our range is from 0 is less than or equal to, in this case, d, to 100. Part C says estimate Maria's distance from home after 3.5 hours and write your answer using f of x notation. Okay? So when I look at 3.5 hours, it's right here on my t-axis. I'm going to look at the value of the function there, so I'm looking at where that would be. And we have 50, we have 75, and we have 100. It looks like it's about, part way between 75 and 100, and we're estimating here. So when we do that, I'm going to write it like this. I'm going to say f of 3.5 hours, so my t value is 3.5, is equal to somewhere, looks like, I'm just guessing, but I'm going to go with, say, about 85 miles. So after 3.5 hours, she's about 85 miles from home. Okay. Part D says estimate how much time it took Maria to first be 100 miles from home. So once again, let's look at this and let's see if we can figure out when is she going to be 100 miles from home. Okay. Well, here's the 100 miles, right? So if that's 100 miles right there, and we're looking at when is she first there, well, that looks like that is occurring right there, which is at about 4 hours. So the answer here would be 4 hours. Alright, finally part E says what is the significance of the left horizontal line segment and estimate its endpoints. Well, if you look at the graph, there are two parts of the graph that are horizontal. There's this part right here, and there's this part right here. Okay. Well, the left one would be this one right here. And what we want to know is says what is the significance of this? Well, the left horizontal line would be what would occur first from a time standpoint. And according to the problem, it says the graph below gives the distance Maria traveled in 7 hours. She drove some, then visited a historical museum. So the first stop that she makes is at a historical museum. Well, when she stops, she's not moving forward. Therefore, that would be a horizontal line graphically, because she's basically standing still in terms of her distance. So she wouldn't be going up at all in terms of distance. So that first horizontal line would represent that she visited historical museum. And then the second piece of that problem says estimate its endpoint. So I want to know what this point right here is and what this point right here is in terms of ordered pairs. So it looks like the left endpoint would have to be at 1.5 hours, and it looks like the museum was at about 75 miles, so it'd be at the left one would be at 1.575. And the right one, where she ended her museum stop, was at 3 hours, so that would be 3, and also at 75. So those would represent the endpoints of that horizontal line segment. So at this time, what I'd like you to do is just take a few minutes to go through guided example number 1, and I'd like you to answer each of the questions that they have there. You'll notice that guided example 1 is very similar to the one I just did. Get your answers for that, and do that while you have the video paused. When you're done, turn the video back on, and I'll go through the answers so you can see how you did on that. Take a look, make sure that that's what you had as well. It should be something close to that now. Like part C, there's some estimation, etc. But for the most part, you should have those answers. If you have any questions, make sure you ask about them in class. Next time we can talk a little bit more about that. Okay, the last thing I'd like to do in these 1-5 notes is to take a look at example 2. Example 2 says Robert Wadlow is the tallest person in medical history whose height has been substantiated. At birth, he was of normal height. The table below gives his height h at various ages a, where h is equal to f of a. Part A says, what is the domain of the function defined by this table? Now, a key component to this is it's asking defined by this table. So we're only interested in those values within the table. So as I look at that, the values that would be the domain are the first row of the table. Therefore, and we also know that age a is the independent variable. Therefore, the values that would be the domain are these values right here, which I have listed along the way as well. Part B says, what is the range of the function? Same idea. We're defining it by the table. Therefore, the range is going to be the second row, or the height of Robert. So it would be just those values based on the table. Okay. Part C says, find f of 16. Well, f of 16, that means that instead of a, I'm looking at 16. So his age is at 16 years. And at 16 years of age, he was 2.4 meters high, so it represents his height at 16, and the value is 2.4 meters. Part D says, for what value of a does f of a equal 2.7? So when we're doing that, now we're looking for the value of its height, the value of the age when we know the height is 2.7. Remember that f of a equal to 2.7 is like saying h is equal to 2.7. Therefore, at 2.7 a height, the age was 22. So a would have to be 22.